Hello everyone, welcome to today's Coffee Talk, presented by Dom Daniel and Azure for Technology Partners program. Today's topic is about running Terraform on Azure DevOps pipelines. I'm Violeta, a cloud engineer at Dom Daniel and Microsoft Certified Administrator Associate. During the presentation, if you have any questions, please feel free to leave them in the comments section. My colleagues and I will answer them. If you're watching the recording of this video, please feel free to email or message me your questions on LinkedIn and email. Also, feel free to contact us on Dom Daniel's official pages on Facebook and LinkedIn. Before we go on, I would like to introduce you the Azure for Technology Partners program. The Azure for Technology Partners program offers free of charge business and technical assistance when migrating to Azure. And it also provides validation funding. If you want to join the ATP program, simply visit atp.dom-daniel.com. Now let's get to the core of this presentation and talk about infrastructure as code, Azure DevOps pipelines, and their benefits. With the growing number of infrastructure deployments on the cloud, infrastructure as code emerged to solve many problems. So what is exactly the issue with the traditional deployment? First is the Snowflake configuration. Administrators used to create infrastructure manually and configure the whole infrastructure manually. It used to create some problems because whenever there was a need to recreate the resources, administrators did not remember every single configuration and every single resource. These one-of-a-kind configurations are called Snowflake configurations because they are unique each time they are created. The Snowflake configuration problem even heightens when there are multiple administrators working on the same infrastructure. Even in case of documenting the whole infrastructure and the configuration, it is still impossible to recreate resources exactly. So there is a need to save information about infrastructure and the configuration connected with it. The second issue connected with traditional deployments is the human error. It is impossible to deploy infrastructure without this factor. However, during manual configuration, human factor is considerably high. So we need to minimize it as much as we can. The next issue is the issue of slow provisioning. Provisioning resources manually takes a lot of time and it creates a slack in the process of the deployment. The last issue is the management overhead. Because it takes more time to provision resources manually, there are more administrators needed to perform their jobs. And also their focus is mainly on provisioning and creating resources rather than exploring new technologies and new approaches. To solve all these problems, infrastructure as code has been introduced. Infrastructure as code suggests that the whole infrastructure should be written in a piece of code. This code can be used to recreate resources exactly, and also whenever there's need, we can refer to this code to get information about our resources. Infrastructure as code considerably minimizes the human error. The slow provisioning is kind of eliminated by infrastructure as code, and the management overhead is reduced. So administrators can now perform faster by implementing the newest and most effective technologies. One of the tools that helps to build, change, and version infrastructure safely and efficiently is Terraform. Terraform is one of the implementations of infrastructure as code and uses the notion of the so-called state to keep track of the real-world resources and your configuration. It detects changes between your configuration and the resources on the cloud. Now that we have an idea of what Terraform is, let's understand how it works. All the infrastructure is defined in Terraform configuration files. This diagram shows that the components are in those configuration files. And whenever we are happy with our configuration of the infrastructure, we can perform a plan which executes a plan of what is going to be done and the steps needed to reach desired configuration. If we think that everything is fine, we can apply this plan, and after applying, our resources will be deployed on the cloud. So there are some alternative solutions for implementing infrastructure as code besides Terraform. And some of them are mentioned here, although there are many others. They all have their advantages and disadvantages. And depending on the project, some of them may be used or a combination of them may be used to reach our goals. Let's just notice that Azure Resource Manager templates here are mainly for provisioning infrastructure on the Azure cloud. And Ansible is for configuration and not for creating infrastructure from scratch. Pulumi is also an infrastructure as code implementation. However, it doesn't have as large community as Terraform does. So Terraform is a great tool for implementing infrastructure as code for multiple cloud platforms such as Azure, AWS, Google Cloud, and so on. It also has a really large community and great documentation. Is Terraform perfect? With all the nice features and advantages discussed, Terraform and infrastructure as code in general is not absolutely perfect. It has some drawbacks. The first one, written here, is the accidental destruction of stateful resources. The accidental destruction of resources is common when working with Terraform files. However, deletion of resources is okay because we can redeploy them, but in case of stateful resources, our job gets complicated. Now we have to perform restores and such tasks to get our resources back. However, we should not let this happen, and for that we should put locks on stateful resources such as databases to avoid this situation. The next one is that differences between testing and production environments actually exist. We know that infrastructure as code is simply a piece of code, and a piece of code can perform differently in different environments. To avoid this, we should have exactly identical environments for both testing and production. This is nearly impossible if we are trying to maintain these environments manually. So there's a need to have a single identical platform for deploying our Terraform code. And the last point I want to discuss is consistency. Because many engineers and administrators are working on Terraform code, some of them might not commit their changes, forget to commit, and others might deploy older versions of their code. And also, some administrators may manipulate resources at the same time, which may again create inconsistencies. To solve all these problems, CI/CD pipelines should be implemented. Pipelines provide a single platform to build and deploy your code. And they are considered as single sources of truth for all the employees working on the project. Just like application code, infrastructure code should also be treated the same, meaning it should undergo through this testing and deployment cycle and also use automated deployments. So what does CI/CD introduce? And let's understand CI/CD pipelines. So what the CI part of the CI/CD stands for continuous integration, which allows to treat every single new piece of your code as a new version of your product. After testing your code, it is integrated to a shared repository, and this process happens frequently with small changes to the code. The CD part of the CI/CD stands for both continuous delivery and for continuous deployment. Continuous delivery ensures that your code is consistently ready for new deployments and ensures effortless deployments. Continuous deployment is actually the automation of the deployment, which allows code to reach its customers really fast. CI/CD allows companies to have releases quite often in a matter of weeks, days, or even hours. So let's discuss what else advantages CI/CD pipelines have. So with smaller code changes, CI/CD pipelines have fewer unwanted consequences. There is this notion of the blast radius, which determines how much a small change in the code might have an impact on the whole product. And if our changes in the code base are really small, it assumes that the consequences are going to be small. By doing small changes to the code continuously, the fault isolation is easier, because by doing small changes and observing how the system behaves, we are able to understand where we went wrong. The mean time to resolution, which is the time taken from the point when the incident was reported up to the point when it was solved, is shorter. Because whenever the fault isolation is quick and simple, the mean time to resolution is shorter. So the next advantage of CI/CD is that testability improves. Due to small changes to the code, the test results are more accurate, and also they are implemented in a shorter time frame. Also, non-critical issues do not often rise in the production environment because they are detected in the earlier stages. The next and one of the most important advantages of CI/CD pipelines is that the product evolves rapidly. With small changes, companies are now able to have releases really often, as I said, in the matter of weeks, days, or even hours. And the last point is that our product has more agility. By using continuous deployment, our code reaches its customers really fast, and according to customers' feedback, it can change in a really short time. So Azure DevOps is a Microsoft product, a DevOps tool for developing and deploying code. It is Azure DevOps allows to design CI/CD pipelines for your code, and it works both for application code and for infrastructure code. Azure DevOps has the following components mentioned here: Azure repos, boards, artifacts, pipelines, and test plans. Azure repos is a set of version control tools that helps to maintain and integrate your code. It is a good idea to keep your code in a version control, whether it's a large or a small code base. Azure Repo supports two types of version control. One is the distributed version control, Git, and the other one is a centralized version control, Teams Foundation version control. So Azure Boards helps teams to manage their projects by providing with tools for implementing agile methodology concepts. Azure Artifacts is a great tool, especially for deploying infrastructure. It creates packages and publishes them, and also you can use these packages in your pipelines. You can publish your artifacts in Artifacts feed and also in public registries as well. Artifacts are especially great while integrating code between different stages of the pipeline, like building, testing, and deploying. Azure Pipelines implements CI/CD pipeline concepts to help deploy code faster and easier. Azure Test Plans provides some tools for testing your code. So now let's get into the demonstration. Let's discuss the demonstration setup, the infrastructure of what we're going to deploy. So we are going to deploy 3 virtual machines, and they are going to be in the same availability set. They are going to be load balanced by a public load balancer. Each of these virtual machines holds an application, which we will see after deploying the infrastructure. The whole infrastructure entirely runs on Azure. Let's go to our Azure DevOps and take a look at what we have there. So I have many projects in Azure DevOps, one of which is this one called infrastructure. Let's visit this. So in here, you can see on the left some of the components of Azure DevOps we've discussed. And this one is just an overview page of your project. In here, you can find general information of your project, and also you can see the success rate of your CI and CD pipelines. So without further ado, let's go to our repos. This is our code base where we keep our code. This is the Git version control. All of our code is in the master branch. Next, let's go to this racket sign, which indicates our pipelines. Let's go to our build pipelines. Here we have one build pipeline, and if you want to create a new pipeline, a build pipeline, just create a new pipeline. This automatically creates a CI pipeline for you. Now you have to choose where your code is. We can choose Azure Repos Git. You can also choose Bitbucket, GitHub, and so on. So we can choose this repo for our project. Next, we can configure a starter pipeline from scratch, or if we have an existing pipeline, we can implement this pipeline. Now let's try starter pipeline. Here we see that we have a YAML file, and you can edit this YAML file according to your needs. We already have a pipeline. Let's go and see what it does. Let's visit this pipeline. These are the runs of the pipeline, but we have to press edit to see the structure of our YAML file. The first part of this YAML code indicates that whenever there's a change in the master branch, whenever there's a push to the master branch, this triggers the CI pipeline automatically. The next one is about the machine on which our pipeline runs, and it is the Ubuntu image. So the next are the steps performed in this pipeline, and the first one is authentication to Azure Cloud. Here we use a service principal to authenticate to Azure, and these variables are actually defined right here. Here you can add variables, and you can make them a secret if you don't want anybody else to see them. So the next task is about installing Terraform. You have to provide the right version. This task is for initializing Terraform, and it actually initializes the state in a remote Azure storage account. The next task is for validation. This is where our code gets validated, meaning syntax errors or errors that are quite to catch by looking at it at the first time are right here. If everything runs smoothly, meaning that our code doesn't have any syntax errors, it continues to run. And then these two tasks are for copying files and for publishing them to an artifact. This artifact will later be used in a release pipeline. Now let's go to our release pipeline. We have one release pipeline here. If you want to create a new release pipeline, you just have to press new and then new release pipeline. After doing so, you here have to provide the artifacts and all the stages you need. Let's just go to our existing pipeline. Press edit to see what structure it has. So here we have the infrastructure artifact we talked about in the CI pipeline. This automatically triggers continuous deployment whenever there's a continuous integration build. it enables this pipeline automatically. And in the test stage, we have this gated condition saying that whenever there's an approval from me, this pipeline can run. If not, this pipeline cannot run. So it's a manual approval. And the last stage is for running our tasks in the production. Let's see what kind of tasks we have. And our tasks are exactly the same in the test and production environment. So I will only go through the test environment. Here we have some tasks. Azure CLI task is for authenticating to Azure. This task installs Terraform. This is just a bash script, something simple. And then Terraform has these two tasks, plan and apply. Now, let's go to our code, local code, and make some changes in there. So let me just... Okay, so here we have our Terraform code locally. After implementing some changes, we should push our changes to our master branch on the Azure repo. Okay, let's just add some comment for an example. Let's add, this is a new comment. Save this file. By now, Git should understand that we made a change, and we can add this change. We should commit. And then push. Now it requires a password from our repo. Let's just go to our repository and get this password. Here you can create Git credentials and copy the password. We can paste the password right here. And everything is pushed to our repo. Now let's go to our build pipeline and see what's happening there. It should have been activated by now. Let's go to pipelines. We see that it's in running status. So let's see what is going on inside this pipeline. You can click and see the logs. So here our code from the repo is being checked out. And all the tasks we talked about are being performed, like Azure authentication, installing Terraform, and other tasks. As you can see, this takes just a little time. And at the end, it publishes the artifact, so the release pipeline can use it. Everything looks great. Let's go to the releases. Let's wait for a release pipeline to activate. Oh, it has been activated. Also, whenever there's a build success, it sends a notification to your email. You can disable this feature if you don't like it. So it's already started running the release pipeline. And here we have a notification. It says that the build has succeeded. That's great. We can see the logs of the release pipeline as well. It has run almost all of the tasks. While it's running the tasks, I want to show how the test and production environments are separated. Here, the Terraform workspace feature is used. And in the test stage, it is set to test, while in the production stage, it is set to prod. So our test stage has been completed successfully. Now I need to give my approval for it to continue to the production stage. Let's just approve this. And here, here you can have a comment saying approved by me. Okay, now let's approve. You can see that our production stage has been queued. Let's go to the logs. Before this runs, let's just go to the variables section and see that our workspace, meaning our environment, is set to production right here. Our Terraform plan is currently running and we only have Terraform applied to run. Let's just wait for a few seconds. Well, everything looks fine. Our deployment has succeeded. We can see the whole pipeline right here. Now let's go to our Azure portal to see what resources we have created. So here is the production resource group. We also had a test resource group, which actually has the same infrastructure. Now let's see how our applications work. Let's just copy the IP address of the public load balancer and just, so this is load balancing among three virtual machines. This is the first one. Let's just refresh to get the others. This is the 0. This is the second one. So everything looks fine. That's it for the demonstration. Let's go back to our slides. So this is the part where I answer all your questions. Let's go and see if you have any questions. No questions. I hope you will message me on LinkedIn or email me your questions if you have any. Thank you for attending this coffee talk. Please make sure to follow Dom Daniel's pages on Facebook and LinkedIn to get updated for more interesting coffee talks. I want to remind you again about the Azure for Technology Partners program, which enables partners to receive free of charge business and technical assistance while migrating to Azure. Thank you for attending again, and see you on the next coffee talk. Goodbye.